Okay, so what we're going to do right now is we're going to talk about polynomials and how to graph them. And we're going to do this from an algebraic perspective. We're not going to be using any calculus. And the difference is going to mainly become when we're using algebra, the number of turning points can sometimes not be clear. But using algebra, the things we know from algebra, we can at least put a bound on them, and in some cases know them exactly. And you'll see what I mean. But there's no calculus here, just all algebra is what we're using to graph. So we're going to look at f of x is equal to 8 times x plus 4 times x minus 7 squared. Okay? So what we want here is, first of all, our first objective is going to be find the zeros. Okay? And for that, I'm going to take my factors and set them equal to 0. And my first factor is given by x plus 4. So I'm going to take x plus 4 and set it equal to 0. Now note, my factors, when a function is factored, I just have parentheses back to back. There's no addition in between the sets of parentheses. It's just all multiplication. X plus 4 times x minus 7 squared, right? So my first 0, I'm going to take my first factor, set it equal to 0. I'm going to solve for x. And I get x equals negative 4. So this is my first 0. Okay? Now, the multiplicity of this 0, I look at the factor associated with that 0, which is x plus 4, and I look at the number of times it occurs in the function. Well, there's a 1 up here, even though we don't always write it. So the multiplicity of this 0 is given by 1. Okay? And what that means is it's an odd multiplicity, so the function is going to cross the x-axis. And you'll see more what that means. Now, for my other factor, I have an x minus 7. So I'm going to say x minus 7 is equal to 0. And I'm going to solve for x. I'm going to have x is equal to 7. Now, this is my 0 right here. And to see the multiplicity, well, 7 is associated with the factor x minus 7, which occurs a total of 2 times. So the multiplicity, you might want to think where it is while I'm still writing, is 2. And that means it's going to touch the x-axis and turn around. Okay, and that's because it's an even multiplicity. Okay? Now, the next thing, what this tells us is we have the multiplicities, which give us some important information, and we know the zeros. And this also tells us that when x is negative 4, the function is 0, which is the next intercept. And this tells us that when x is 7, the function value is 0. So this gives us the x-intercepts. Okay? Now the next thing I'm going to look at is the y-intercept. And to find the y-intercept, I just plug in 0 for x. And I'm going to have f of 0 is equal to 8 times 0 plus 4 times 0 minus 7 squared, which is going to be equal to 8 times 4, and negative 7 times negative 7, or say negative 7 squared, because 0 minus 7 is negative 7, which is going to equal to 8 times 4 times 49. which is going to be equal to, well, 49 is 50 minus 1, and 50 times 4 is 200, and 200 times 8 is 1600, and 8 times 4 is 32, so this is going to be equal to 1600 minus 32, which is 1600 minus 30 is 1570, and 1570 minus another 2 is 1568. Or you could just do 8 times 4 times 49 on your calculator. Okay? So that tells us that when x is 0, the y value is 1568. So the y-intercept is given by 0, 1568. Okay? So now what we do is we know the zeros, and those correspondingly gives us the x-intercepts. By looking at the multiplicity of the zeros, we know how the function is going to behave when it touches the x-axis. We also have the y-intercept, which helps us graph the function by plugging in 0 for x. Next, we're going to look at the end behavior. And for the end behavior, I'll just rewrite the function up here. We have f of x is equal to 8 times x plus 4 times x minus 7 squared. So what does that tell us? It tells us that, well, if we multiply this whole thing out, and we could then use the leading coefficient test, but that's a lot of work. So here's a little trick. This is the same as 8 times x plus 4 times x minus 7 times x minus 7, right? So for large values of x, the only things that are going to matter are the 8s on the outside and the highest order term with each factor, which in this case, there's the highest order term here is just an x, the highest order term here is just an x, the highest order term here is just an x. So we're going to do 8 times x times x times x. That tells us for really large values of x that the function is roughly equal to 8 times x times x times x, which is equal to 8x cubed. If I multiply this whole expression out, the first term, the highest order term I would have would be 8x cubed minus or plus something x squared plus or minus some x plus a constant. But for large values of x, it's roughly x cubed. It's a little trick. And so the leading coefficient test, the coefficient is positive. And the order is odd. The order of the power, if you like. That means for large values of x, the function falls to the left and rises to the right. Okay? Right, because the order is odd and there's a positive coefficient here. All right. And what we can do here now is we need one more thing. So that's the leading coefficient test. I'll just put leading coefficient test for LCF. We know that the function for large values of x is going to rise to the right and fall to the left. Now the last thing we're going to use to graph this is the number of turning points. Well, we know since this is the higher order term, we know it's a third degree polynomial. And the maximum number of turning points is the degree minus 1. So since it's the third degree, 3 minus 1 is 2. So we have, at most, 3 minus 1 equals 2 turning points. Okay, so now we're ready to graph this guy. So to graph this, we're going to, first of all, we're going to put our intercepts in. So our first intercept was 7, 0, which was given right here. So we had 7, 0. So we're just going to go and plug that in, and we're going to have, when the function of the x value is 7, the y value is 0. And our other intercept was -4, 0, which is given right here. When the x value is -4, the function value is 0. We're going to go 1, 2, 3, 4 from right here. That's going to be -4, 0. And that's going to be 7, 0. And then we're going to have is we also have next we're going to have the y-intercept. Let's put all the intercepts first. When x is 0, the y value is 1568. So let's go by hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900, 10, 11, 12, 13, 14, 15, 16. So it's going to be like right here. And that is going to be when x is 0, y is 1568. That's the y-intercept. And now what we're going to do is we're going to look at the behavior at the zeros. And the behavior at the zeros, if we look at this, for this x-intercept, it's going to cross the x-axis. And the multiplicity is 1, so it's going to go straight across. So that means that as it crosses this axis, the function is going to do something like that. It's going to be a straight line. If it were a 3 or a 5 or higher ordered expert, it might snake across or something. And for this 0, the multiplicity was 2, so it touches and turns around. So it's going to have to do something like this. And the reason I know it touches and turns around from the positive, because it has to connect from a point up here. So if I draw this, if I start from my furthest 0 out, I know the function has to fall as it moves to the left. And if I start from my farthest 0 here, I know it has to rise as it moves to the right. Now, my guess is that the function is going to have to connect like this, and the reason it'll have to, because you'll note I can have at most 2 turning points. So I have 1, 2. It might look a little different from between somehow, but this is essentially what the function will look like. And that's the analysis of this polynomial, and that's essentially what the graph of f of x equals x+4 times x minus 7 squared looks like. Okay, that's all I have, and I hope that answers your questions, and I hope you have a wonderful day. Thank you. Bye.